Greetings everyone, NVIDIA has released their newest driver along with an amazing extension made for Stable Diffusion Automatic1111 Web UI interface. So what is it? It is RTX Acceleration with TensorRT. When we go to this announcement page, you will see that up to 2 times speed up with GeForce RTX 4090. In this tutorial, I will show you how to install this amazing extension and how to use it step by step. Why you should follow this video? If you want to obtain up to 70% speed improvements, then you should follow. Let me show you some of the comparisons. For example, when used on Stable Diffusion 1.5 based model and 512 by 512, you see from 19.30 IT second to 30.87 IT per second we are reaching with RTX 3090 Ti. It uses a little bit more VRAM, however it is totally worth it. There is a huge speed improvement from 7.94 to 13.75 IT per second, and for SDXL the speed is even more amazing from 3.61 IT per second to 6.04 IT per second, and these are obtained with relaxed TensorRT, not for static. You will understand what I mean when you watch the entire tutorial. With making static resolution TensorRT models, you can get over 70% improvements as you are seeing here. So watch this tutorial, do not miss it. Watch every part of this tutorial. So for this tutorial as well, I have prepared an amazing GitHub Readme file. The link of this file will be in the description of the video. Please do not forget to start my repository. Follow me on these platforms. It is helping me hugely, and don't forget to subscribe to our channel. So I will begin with installing a fresh installation of Automatic1111 Web UI. If you don't know how to install Automatic1111 Web UI, please watch this amazing tutorial where I have shown how to install Python, Git and Automatic1111 Web UI. You need to have Python and Git to follow this tutorial. I will use my automatic installer. The link is here. I will also show how to install everything, how to install RTX Acceleration with TensorRT step by step as well. So this tutorial will cover both for my Patreon supporters and for my non-Patreon supporters. I will show every step, don't you worry about that. So all the files are here. Let's download all files.zip file from here, or you can download from the attachments. This is not mandatory, but for fresh installation I will use it because it is easier for me to do. So let's say fresh one. Let's enter inside it, extract here. You can skip this step if you already have a fresh installation of Automatic1111 Web UI. So let's begin the automatic installation. This will do everything for us automatically. As I said, if you don't know how to install Auto1111 automatically, follow this excellent tutorial. I have shown step by step how to do it. So the automatic installation has been completed and the Web UI started. First of all, go to the settings and in here find the user interface, which is here. Click there. Here go to the info quick setting list, search for SD and select SD UNET and search for VAE and select SD VAE. After that, apply settings and reload UI. So after the reload, you will have SD UNET and SD VAE options here. My automatic installer automatically downloaded Realistic Vision version 5.1, SDXL base 1.0, SDXL Refiner and SD 1.5 base model. It has downloaded best VAE for SDXL FP16 version and best VAE for SD 1.5 based models. I also made another installation, another fresh installation, fresh 2. So on fresh 1, I will show my Patreon script automatic installation, and on fresh 2, I will show manual installation. The next step is installing the extension. Which extension? The Stable Diffusion Web UI TensorRT extension. The link is on the GitHub Readme file. So this is the extension that is developed by NVIDIA. Can you imagine that? NVIDIA is officially developing an extension for Stable Diffusion Automatic1111 Web UI GitHub repository. That is amazing. That is amazing. This is where AMD is lacking. This is where actually Intel also started to support it. So this is where AMD is lacking. We are going to install this extension. Let's install it automatically first, then let's install it manually. So in my fresh one folder, I have automatic installer for this extension. All you need to do is double click install TensorRT .bat file. It will install the extension into the accurate folder. It will also download and install the latest cuDNN file for you fully automatically. Don't you worry, we will also download it from here manually. So if you don't have my Patreon supporting, you will know how to install it. Moreover, I suggest you to install latest game ready driver, which is released by NVIDIA very recently. The driver link is also here. You see NVIDIA GeForce drivers. I also compared 536 to 545, which is the latest driver. I didn't see any speed changes with my RTX 3090 Ti GPU. Actually, I had also recorded that part, but since there were no speed changes, I am not going to include that part into this video. But for TensorRT, I suggest you to install latest game ready drivers from here. So the automatic extension installation is completed. It also downloaded and replaced latest cuDNN files as you are seeing right now. All we need to do is now start the Automatic1111 Web UI one more time. Moreover, this is the only command line argument I am using. I suggest you to test this extension on a fresh installation first. Once you make it working, then you can use it on your existing installation. So now it will install the extension and its dependencies. There are still some issues with the extension. It is not still fully stable yet. It is getting developed by an active developers. I am also very active here, opening issues, doing pull requests and other things. So just wait when the first time it is getting installed. Meanwhile, let's also do the installation on the manual installation. So let's start the manual installation. If you are not my Patreon supporter, this is how you are going to install. Let's start the Web UI. So this one is now installing the dependencies of the extension. Okay, it is loaded. Let's also make the same changes from here. User interface, VAE, this is my manual installation, and SD UNET, apply settings, reload UI. So how you are going to install this extension manually? Copy the URL. You can also copy the URL from here, right click and copy link address. Go to extensions and in here go to install from URL, paste it there, install. Alternatively, you could clone it manually into the extension folder. How is it done? It is so easily done. Go to the extensions folder and in here open a CMD. Like this, you see while you are inside extensions folder, type git clone, paste the link and hit enter, and it will clone the extension into the extension folder, then restart the Automatic1111 Web UI. But you can also alternatively use install from URL. If you use install from URL, it will install dependencies as well. You will also get this error even though when you have installed the latest cuDNN file. This is the mistake of extension. Still not fixed, but it will be fixed. You can ignore this. So click OK to all of the errors and extension is installed. Now it is ready. Let's close this. This is how you install extension. So as a second step, for my automatic installation, you don't need it, but for manual installation, you should upgrade your cuDNN to latest version. The link is here. There are actually two links. Let me show you. This is the official website for NVIDIA cuDNN, and in here you are supposed to download cuDNN version 8.9.4, which is released on 8 August for CUDA 11.x. This will ask you to register and log in NVIDIA developer site. It is free. Just register and log in it. Then download the local installer for Windows. My Patreon supporters don't need this step, but if you are not my Patreon supporter, do not skip this step. This is important. Then what you are going to do is you are going to enter inside your installation Web UI, enter inside VNV folder, virtual environment folder, enter inside library folder, site packages. In here, go to the NVIDIA, in here go to the cuDNN, in here go to the binary. So this is the path where you will put your downloaded cuDNN files. It will upgrade your cuDNN files to the version that you are going to install. So it is inside installed downloads folder. Here I copy paste it here, extract to cuDNN Windows. I am using WinRAR for extract, but Windows already has that. So enter inside the downloaded file library binary. This, cut them and go back to binary here and paste them. It will ask you to replace all of them. And how can you be sure you are using the correct version? For example, click one of them, click properties, and when you go to details, you will see the product version. This is showing the cuDNN version. This is automatically done with my automatic installer. Okay, so now what? Let's start our web UI one more time. And now we will generate TensorRT versions of the models that we are going to use. Each time we are going to get this error even though we are using the latest cuDNN file. Okay, so let's say you are wanting to use Realistic Vision version 5.1 with the TensorRT. Let's see the speed without TensorRT. So this is the best VAE file. Okay, as a prompt, let's go something with simple photo of an amazing, expensive, luxury sports car. Okay, it is not important. I am preferring DPM++2M STE Caras. I find that this is working best. So let's see the speed with 512 and 512. Okay, it is 16.31. Let's generate another one. 16.5. I am also recording a video right now, so it is not the best speed, but this is the speed for 512. And let's go with 768 to 768. Let's generate. Okay, this is the IT per second. It is like, let me show you. It is like 7 IT per second. So let's generate its TensorRT. Go to this tab. This is what you need to do for each model and each LoRA. You have to generate a TensorRT version. I suggest you to generate batch size and make it dynamic. What I mean, so select batch size option here, let's say 768. Click advanced settings and do not use static shapes if you want to generate multiple different resolutions and which batch size you want to generate. I prefer batch size 1 currently, but let's say min batch size 1, optimal batch size 2. If you are going to generate images with batch size 4, then make the optimal 4. And maximum batch size, let's make it 4. These are important. If you don't set these and try to generate images later, you will get error. So what is the minimum height I would like to generate? It is 512. Optimal. So you may be wondering, what does optimal mean and max meaning? Mean means the minimum height your TensorRT will support. If you are going to generate images below that, you will get errors. Optimal means that it will be most optimal. It will do the best speed with that resolution. So if you are going to mostly generate with 768, then it should be 768, or 512, then it should be 512. So what would be the maximum resolution that I am going to generate with this model? Let's say 1536. This is the double size of this one. Let's select same for width 2. So we are setting for each dimension height and width. So min prompt token, this is also important. What is the prompt count that you are usually using? Let's make this 75 minimum. Let's make it 550 optimal and maximum 225. And if you already have an existing TensorRT, then you should click force rebuild. When you first time export engine, it will look for ONNX file. You see, it says no ONNX file is found. Exporting ONNX file. And where is this exported? This will be exported into UC ONNX temp folder first. Then it will be inside models, inside UNET ONNX. We will see the model file here. This file generation may use a lot of VRAM. Unfortunately, as far as I know, each GPU line requires different rebuild. For example, I have RTX 3090, so all of the RTX 3000 series can use my generated UNET files. I don't know if they can use ONNX files, but they can use UNET files. So if you are my Patreon supporter and if you have 3000 series, I can generate, compile UNET files for you and upload them to the Patreon for you, and you can use them. Message me on Patreon for that. If you don't have a sufficient VRAM, I think it still should work, but it will be slower than what it is on my computer. So you see, Realistic Vision version 5.1 ONNX file is generated. By the way, this file is not necessary. You can delete it after your UNET file, which will be inside UNET TRT, is generated. So the TensorRT file will be here. Each time when you generate a new TensorRT file, it will update this model.json file and it will append it here. So this is really important. This file, without this model.json file, you won't be able to use them. So now it is generating the TensorRT file. Once this operation is completed, we will be able to use it. This part is actually much faster than ONNX file generation, and it is also using much lesser VRAM, as you are seeing right now. By the way, it is super important that if you set your command line arguments as --met VRAM or low VRAM, you will get an error in this part. Let me show what I mean. So this is our file where we set the command line arguments. So if you have --met VRAM or --low VRAM, remove them when you are generating your TensorRT files. These will cause errors. Moreover, with TensorRT, use Xformers. I suggest you to use Xformers. So this is all the command line arguments I have. Another thing is that if you have custom extensions, they could conflict with this process or with your TensorRT. So if you get an error, do a fresh installation of Automatic1111 Web UI, then generate your TensorRT files. As I said, this is still in development, but it is hugely improving the speed. We will see that in a moment once the file has been generated. And if you want the maximum performance, instead of these custom sizes, you can make them static shapes and it will be faster, you see. But it will only support this height and this width and this number of batch size and optimal prompt token. So do not forget that. If you need dynamic ranges, then set them like this as a dynamic range. Follow the output here and also on the CMD window. Okay, it is still working and the engine is about to be generated, and it is generated and save it to the disk. So when I now refresh this SD UNET, you see it is here. When this is set to automatic, it will automatically use the UNET. So what was our speed? Our speed was for 768 resolution 6.91 IT per second, if you remember. So let's load the same seed. Also, let's see the seed difference. So this is the latest seed and everything is same. Let's generate and let's see the speed. So it is going to load the UNET. Okay, it says that no valid profile found. We need to switch to the development branch of Automatic1111 Web UI. What does this mean? The Automatic1111 Web UI has several branches. So when you click branches, you will see master and you will see test FP16 and development branch. So the development branch was last updated 5 days ago, and there is also test FP16. For now, I will go to the development branch. Let's switch to the development branch. How you are going to do that? If you are my Patreon supporter, this download TensorRT enable.bat file has switched to development branch automatically. So let's hit 5 and we are now switched to development branch. Alternatively, open a CMD window inside that folder, inside your Stable Diffusion Web UI folder, type git checkout dev and it will switch to dev. If you want to return to the original, git checkout master and you will return back to master. So let's go back to the development branch and let's restart the Web UI. Once this development branch is merged with the master branch, you won't need these changes. But for now, we need to do this. This is also mandatory for SDXL TensorRT. So let's load the latest values from here and let's try again. Okay, this is weird. Okay, maybe we should try one more time. So I will go with 768. Let's make the optimal height 512, optimal width 512. Actually, let's make it like this. 512, 768, 1569. This is interesting. I wonder if it is caused by something else. Maybe it was because of the prompt token count, so I will not change it. And okay, it says that export default installation supports. Maybe it is not able to support over 1024. Yeah, let's go with 1024 like this. And when we click export engine, okay, it starts to export again. You see, it will not generate the ONNX file one more time. It will use the existing ONNX file, and it started rebuilding. Okay, it is generated. Even though I have sufficient VRAM, it shows some error messages, but I think they shouldn't cause any errors. So let's refresh the here, and maybe let's make it automatic and try again. Okay, this time it looks like working and we got the image. Let's see. Yes, it looks like the correct image. Let's compare them. Almost same. Not exactly same, but almost same. As you are seeing right now. Very good. Okay, so let's see the speed. Let's generate one more time. Wow, the speed is amazing. You see, from like 7 IT to 12 IT, we got about 70% increase. Let's try another resolution. Last time probably it was because too big, therefore why it failed. Okay, this is another custom. Wow, working. You see the resolution and the speed, it is amazing. 512 to 1024. Let's try 1024, 1024. Okay, this is another one. And you see the speed, it is almost 6 IT per second. All right, what if you are my Patreon supporter? As I said, you can use this download TensorRT enabled SDXL file, and you can download all of the precompiled models for this. If you request me more, I will do that for you, hopefully. So let's also generate a TensorRT for SDXL2. First of all, make sure that you have selected the target model from here. Let's select it, SDXL base 1.0 version. It is getting loaded. Okay, and let's select the best VAE from here. I don't know if VAE selection is necessary, probably not, but to be sure. And let's generate the same image with SDXL base version. Let's look at the speed. The speed is 3.14 IT, 3.13 IT per second. I am recording a video right now also, and the image is getting generated. Okay, here the image. Let's go to the TensorRT and let's select this batch size. I will make it one more time like this. Let's say 768, 1024, 1280. Let's make it 1536. I hope this works. Okay, let's try one more time. Let's make this 512 actually. And 512. Okay, 1024, 1536. Okay, like this. By the way, use the arrow keys here instead of entering them if you are going to enter something custom. I'm not going to change prompt and the batch sizes, but prompt changing is also important if you are going to use too big prompt. And export engine, since there is no ONNX file, it is going to first export it like the last time, then we will be able to generate it. By the way, it looks like downloading something from the internet. It is interesting. Yeah. Oh, not this one is downloading. The download is from the other CMD window we started, which is downloading the pre-compiled TensorRT files. My bad. Yeah. So it is generating the ONNX file for the SDXL base version. For SDXL to work, for SDXL TensorRT to work, you really need to switch to the development version of the SD Web UI. And when you start your Automatic1111 Web UI, you will see there is an additional info here, which is the development branch version. That is really important. Okay, ONNX generation has been completed. It automatically started generating TensorRT file as well. And now it is generating the TensorRT file for SDXL base version. Let's look at the ONNX. It is here, 5 gigabytes. But the real file that will be used will be here, UNET TRT folder. By the way, you can have multiple TensorRT for each model. And if you select automatic option here, according to your settings, it will automatically select the accurate TensorRT configuration for you. So theoretically, for each dimension, you can generate different TensorRT configurations and let the application pick the best one according to that. Let's just wait for TensorRT for SDXL base version to be generated. So the TensorRT file is generated. Let's refresh the SD UNET. Now it is here, and let's generate another image right now and see the speed difference. Last time it was like 3.1 IT per second. Wow, you see now it is over 5 IT per second. The speed increase is huge, definitely huge. And we got our car. Let's generate another time, and it's working amazing. So can you generate TensorRT file for your custom-made DreamBooth training models or LoRa's? Yes, now I will show you that. I have an amazing checkpoint I trained it myself on. Let's load it. Let's select some prompts. I share all of my amazing prompts on Patreon, and I am preparing the very best SDXL DreamBooth training tutorial right now. I am still working on it, so I am also generating some samples. Let's select some of the prompts here and see the speed and TensorRT results. Okay, so for example, let's go with this one. Okay, here the file is loaded. This is also using ADetailer as well. Oh, the ADetailer extension is not installed, so let's go to here, available load from ADetailer. Let's install it quickly. With ADetailer, you can automatically inpaint your face after each generation and have an improved face in the final output. What does it do is it is automatically masking your face and inpainting with the parameters, prompt and settings you give. It is not different. By the way, TensorRT is also supporting inpainting as well, and it is amazing because of that. Okay, for ADetailer to be fully installed, let's apply and restart UI. You see, these were the ADetailer necessary packages. Okay, I think everything is installed. Yeah, every time we get this error, it is very annoying. I hope the developers fix it as soon as possible. All right, let's select the model one more time. Actually, I will try another prompt. So let's go with this prompt. Let's send to the text to image tab. With SDXL, you don't even need negative prompts. It is amazing because of that. Let's make this random for the steps. Okay, and ADetailer here. All right. Okay, everything is set. Let's generate one image and see the speed. So the speed is around 3.15 IT per second as expected. It will also do face inpainting. With ADetailer, it will also take some time. You see, it is inpainting face. The face inpainting speed is also same. And we got the image. Now let's generate the TensorRT version. So this model is selected, and let's go with 10 for batch size 1 static export engine. And since this is a different base model, it is going to generate ONNX file one more time. We have to generate different ONNX and TensorRT file for each model. I hope the NVIDIA overcome this issue and make it on the fly speed up, but this is better than nothing, and it is extremely super useful. Okay, so the TensorRT file has been generated for my custom model. Let's refresh here, and now it is here. Let's generate 9 images, batch count but not batch size. Batch count 9 will generate images one by one. Batch size means it will generate in parallel, but we didn't set this for parallel generation. Okay, the IT is superb. You see 6 IT per second on RTX 3090. It was 3 IT previously. It is almost double speed. This is amazing. This is superb. And you see in face inpainting, it is still also very fast. So it is working amazing. Let's see the results. Okay, the results are generated. Let's look one by one, for example. Okay, this is fully zoomed in. That is why not very high quality, but okay, let's try another prompt, but the results are really good. And since it is fast, we will get much better images with just trying more. If you wonder how did I train this model, the configuration file and quick tutorial are shared here. And I also have an amazing prompt list. So from this prompt list, let's look at the prompts. It also has a text file as well. Let's open the PDF file. And in here, there are unique prompts and the generated images as you are seeing right now. So we can use any of them. Let's try this one. Okay, you can also download image like this, save as. Let's download to the downloads. And let's move to the PNG info. Let's go to download. It should appear in a moment. Oh, this is not the correct one. Let's go here. Okay, let's select it. Okay, it is appeared. Let's send text to image tab and everything is set. Okay, let's remove this. Okay, let's generate 9 images with this prompt and see the result. You see the images are generating very fast and face in painting is improving the face. We got the results and amazing quality as you are seeing right now. One another thing is that this model is generated from very poor quality images. Why? With purpose. Because I am preparing an amazing full tutorial for SDXL DreamBooth and I am using deliberately a low quality dataset. Let me show you my dataset. So this is my dataset. From this dataset, we get these images. Why I am using poor dataset? Because you will be also able to get amazing results even with not a good dataset. When you use a better dataset, you will get even better results. And now let's see how we can combine this with LoRa's. I am going to download SDXL Pixel Art XL LoRa from Sweet AI. Okay, it is downloaded. Let's put it into our models LoRa folder so we can use here. Okay, then let's select the SDXL base version from here. And I'm going to use this prompt. Let's copy it and let's copy the negative prompt as well. And let's make this automatic and let's also add the LoRa. When you refresh, you should see your LoRa here. You will see your LoRa only if the SDXL model is selected here. Because if you have selected not SDXL model, the SDXL LoRa will not appear here. The vice versa is also valid. So if you have selected SD 1.5 based version model here, only SD 1.5 based LoRa's will appear here. And let's generate. Probably we will not get a speed boost or the LoRa will not work. Let's see. Okay, we got the speed boost. We need to also change this to resolution. All right, let's try again. Yeah, the speed boost is effective, but I think the LoRa is not effective because we didn't generate the LoRa TensorRT yet. So let's make this seed. Let's go to TensorRT. How we are going to generate a LoRa? We go to the TensorRT LoRa tab, refresh, and yeah, the LoRa is not appearing. So we need to restart the Web UI. This is a bug that is not fixed yet. So I'm going to restart the Web UI. Okay, Web UI has been restarted. So let's load the latest values from here. Let's come look to LoRa. Yes, the LoRa is looking correct. Pixel art. All right. And let's try one more time. Then I will generate the TensorRT file. Okay. Interesting. Did it generate the LoRa? No. But it is as if worked. It is like half speed. Interesting, very interesting. I think it still used the LoRa, but it didn't improve the LoRa speed. Weird. Okay, let's go to TensorRT, TensorRT LoRa, select the LoRa and convert to TensorRT. TensorRT LoRa generation should be faster. For even LoRa, it is generating an ONNX file. Let's also look at the generated ONNX file, which should be inside models, inside here. And do we see the file? Not yet. Okay, let's just wait. I think this is because the default preset was selected and it is regenerating a default preset LoRa for us. So we probably need to change it. And it shows in the bottom here the available profiles we have. You see we have a profile 0 for SDXL base, which has minimum, optimum and maximum heights. Probably we should have selected it, but I don't know if there is a way to select it since it's a custom profile. When we selected this, I wonder if it was showing the last one. Anyway, this is why probably it will generate another model. So if you ever wonder what your profile consists of, click refresh here. Oh, since it is generating, the refresh will take time. I should have waited. So when it is generating, the refresh will also wait. But we can see the profile already. So the profile 0 for realistic vision version 5.1. This is minimum height, optimum height, maximum height, page size, minimum, optimum and maximum page size, and text length. So based on these profiles, They are working. Oh, now I see the profile one for SDXL base 01. This is a new one that is being generated for our LoRa, as you are seeing right now. It is getting generated right now. I had an error, so I restart the web UI and I also selected force rebuild this time. So if you get an error, select also force rebuild and try again. Make sure that accurate models are selected here on the top. Okay, I found the error reason. First of all, you need to generate your TensorRT profile and then select that profile from here, and then you need to generate your LoRa. Otherwise, it will not work. So what we need to do is, first we need to generate an engine based from here. And then we need to generate the TensorRT LoRa. So let's make default preset engine for SDXL base model, and then we will be able to generate the TensorRT LoRa. Since I have a ONNX file for SDXL base, it is just going to generate an TensorRT default preset profile here. Alright, so the TensorRT generation has been completed with default preset, and we can see the presets here. When I click refresh here, you see now we have two presets for the SDXL base version. Let's go to the LoRa and refresh. Okay, it is not visible one more time, so we need to restart the UI one more time. Let's do it. I will restart the web UI. I'm not going to delete the parts where I had errors. Why? Because so that if you encounter similar errors, you can solve them yourself. Okay, we are going to get this error, this annoying error. I hope it gets fixed very soon. Okay, it is loaded. Let's go to TensorRT. We have selected the default preset. Let's refresh. LoRa is selected and convert to TensorRT. It says no TensorRT engine found building. Now, let's see. Loading bytes. Let's look at the messages. It says loading TensorRT. Yes, we are still having issue for some reason. I tested this on SD 1.5. It was working. I wonder what is the reason for SDXL LoRa is not working. I will report this to the developers so it may get fixed when you are watching this video. Okay, instead let's try SD 1.5 based model LoRa Tensor. So I'm going to download this LoRa. I will also report this error as I said. Maybe this could be related to Automatic1111 Web UI as well. Okay, let's move this into the LoRa folder. Models LoRa. All right. So now when I refresh my LoRa's, it shouldn't appear. Yes, because I need to select SD 1.5 based version. Let's select realistic vision because we already have a TensorRT profile for that. Let's also select the correct VAE file. Let's go to the TensorRT. Let's refresh. Still not showing. Refresh here. Yes, the LoRa appeared as you are seeing right now. Let's refresh. Yeah, we really need to restart one more time. Okay, I'm going to restart right now. So when you add a new LoRa, you need to restart the web UI. If we get error, I will return back to the main branch of the Automatic1111 Web UI. That could be the reason. And we already have a profile for realistic vision. Okay. Okay, web UI started. Let's go to TensorRT. Let's refresh. Yes, now we can see the LoRa. Convert to TensorRT. It says it is exporting ONNX file. Okay, let's look at the export. Okay, this worked very fast. It exported, you see, XRS 2.0 realistic vision version 5.1 ONNX weights. So probably it is not working with SDXL yet, but it is working with SD 1.5 based models. Let's try an example here. Photo of a car. Okay, let's try this. And I am not going to add first the TensorRT. Let's generate an image. So it loaded the UNET from realistic vision. Okay, what do I see? Yes, it is working great. The speed is amazing. Okay, then let's add the LoRa. Okay, I have added the LoRa. Let's generate again. And let's generate again. Yes, the speed is amazing. Does it use the LoRa TensorRT? I'm not sure. Can we select it from here? Yes, let's select it from here and try again. Okay, okay. Yes, now working, I think. Yes. You see the output difference? I think we need to manually select LoRA TensorRT from here. Now the output is really different. Let me show you the difference. So I will make this seed. I will remove the LoRA and I will return back to realistic vision TensorRT. Let's try again. And you see completely different picture, different style. So the LoRA is working and LoRA TensorRT is working as well, as you are seeing right now. So this is how you use LoRa's. Actually, it is changed again. I think there is a bug. So it was working, but not working right now. Let's see what could be the reason. Let's add again. TensorRT is selected. Because this is in development, so sometimes maybe we need to restart. Oh, I see. After I did refresh, now it is effective. Yeah. There are some still bugs. I think they will get all fixed in near future. But as you are seeing right now, it is working. It is super fast. The IT per second is super fast, even though I am recording a video right now. So this is it. I hope you have enjoyed. Please subscribe our channel. When you go to Stable Diffusion, when you click here, you will see the options of starting our repository. This is super important. We have over 1K stars. I appreciate all of you. Please start it. Please also fork it and please also watch it. If you also sponsor me, I would appreciate it very much. Currently, I have 0 sponsors on GitHub, but you can also support me on Patreon. Moreover, I have all the links here: Patreon, Buy Me a Coffee, Medium. I am sharing amazing articles on Medium, Sweet AI, DeviantArt. Follow us on YouTube as well. Subscribe our channel. Follow me on LinkedIn. You can also purchase my Udemy course and you can follow me on Twitter. I am very active on Twitter. If you have any questions, please ask me through YouTube or you can open an issue here. I am replying all of them. I am super active. Currently, my full-time income and work is AI and you guys. Because I left the university this month, hopefully I will start another university very soon. It will be a remote education. But currently I am 24 dedicated to you. I am also doing consultation. I am also doing side projects. I am also doing model training, client helping. I am open to every kind of collaborations. And the links are here. I will update this file if it be necessary. Thank you so much. Hopefully see you in another amazing tutorial.